Friday, we started working on a flip chart review for solving quadratics just to remind ourselves of the different parts of solving quadratics so we could do some review on them before our benchmark later this month. So this first, here's a picture of what our flip chart looked like. Our different tabs were vertex forms, square roots, graphing, factoring, and quadratic formula. And the last two are the ones that we still need to do. But just to review through the others, we had our vertex formula here. F of x equals a times x minus h squared plus k. hk is the vertex of the parabola. H also gives you the axis of symmetry. A lets you know is it going to be opening up or down, and if it's narrow or wide. And then we had square roots. We use this when there is no b term. So example, ax squared equals c. We want to isolate the x squared term to one side and take the square roots of both sides, the positive and the negative. And the reason we take the positives and the negatives because those are giving us our solutions. So here we had x equals 3, x equals negative 3. Those solutions are where the parabola crosses the x-axis. They're also called the zeros of the function because when x equals 3, y would equal 0. When x equals negative 3, y would equal 0. So that's why we call them the solutions the zeros of the function. Then we looked at graphing. And if we have it in vertex form, we already know what our vertex is. But if it's in standard form, we can find our axis of symmetry. X equals negative b divided by 2 times a. Make a table of values, pick 2 points on either side of the axis of symmetry, and then graph. So in our example down here again, here's our solutions. When y equals 0, that tells us when it's going to cross the x-axis. So at negative 3, negative 1. And then we added this comment, if the parabola doesn't cross the x-axis, there are no real solutions. We don't say no solutions, we say no real solutions. Then we were just getting to factoring. So I'm going to start with what would go on the top here on mine. So we started each of these when to use. And we would use this when factorable. And you can usually tell by looking at the numbers if it's something you want to work with, or if nope, this isn't something that I need to be getting into. We need to make sure that it's in standard form and that it is set equal to 0. Then we need to divide by a GCF. And that's if possible, but that's something we should always be looking at before we start any of the factoring process. Then we need to set up the box. And I'm going to do that over here. So we have our box. Remember, we divided into 4. Our x squareds will always go up in our upper left. Our 1s go in our bottom right. And that leaves our x's to fill in the other 2. And to find what those x's are, that's where we're going to use the x method to divide up those x's. And that's where we draw the big X. A times C goes at the top, B goes at the bottom, and then we get 2 factors. And those 2 factors satisfy both the multiplication problem at the top and the sum at the bottom. And we take those and fill in 1 factor in that bottom left, the other factor the top right. Then we factor up each column and across each row of our box. So factor up each column. So it means I'm going to go up, factor what these two have in common, factor what these two have in common. And if nothing else, remember they always have one in common. And then I'm going to factor across the rows. So and across each row. So then we're going to set each factor equal to 0 and solve for x. And that'll give us our solutions or our zeros of the function. So again, that's what goes on the top flap. So now on the bottom flap, down there on the blue, so this is where I'm talking about, is down here. I'm going to be drawing my next slide. So my example here that I'm going to use, 5x squared minus 9x equals 18. So again, that first thing it said was set it equal to 0, so I need to move the 18 over. So 5x squared minus 9x minus 18 equals 0. The next thing was to divide by a GCF if possible. There is nothing that 5, 9, and 18 all have in common, so I don't have that to work with. So the next one would be to set up my box. So again, I know my 5x squared is going to go up here, my negative 18 here. So now I need to know how to divide my 9 or divide my x's at this point. So I go in, this is where I go into my x method. So again, my problem, my a equaled 5, b equals negative 9, c equals negative 18. Again, I want a times c up there, b there. So 5 times negative 18 is negative 90. And then b is negative 9. So I need two numbers that multiply together to make negative 90 and add up to negative 9. Since I have a negative sum, I know the bigger number is going to be my negative. And again, if you're not sure, you can just start working your way through your factors of 90 or negative 90. So 1 times negative 90 would equal negative 90, but 1 plus negative 90 would be negative 89. 2 times negative 45 would equal negative 90, but 2 plus negative 45 would equal negative 43. 3 times negative 30 would equal negative 90, but 3 plus negative 30 would equal negative 27. So I'm getting closer, but I'm not quite there yet. So I keep going. 5 times negative 18 is negative 90. 5 plus negative 18 is negative 13. 6 times negative 15 is negative 90. And 6 plus negative 15 is negative 9. So there is the combination that gives me both my product of negative 90 and my sum of negative 9. So I have negative 15 on one side, positive 6 on the other. So I fill those in. So I have a negative 15x and a 6x that I'm going to fill in. So now I need to factor up each. So 5x squared and 6x have an x in common. Negative 15x and negative 18. 3 will go into both of those, so minus 3. Then I have to factor across each row. 5x squared and negative 15x have a 5x in common. 6x and negative 18 have a 6 in common. So that means my two factors, 5x plus 6 times x minus 3 equals 0. So that's the factored form if I go back to 5x squared minus 9x minus 18 equals 0. So when I factor it, I have this. So then I'm going to take each factor. So 5x plus 6 equals 0 and x minus 3 equals 0. If I subtract 6 from both sides, 5x equals negative 6. Divide by 5x equals negative 6 over 5. Add 3 to both sides, x equals 3. So those would be my solutions to this function using the factoring method. All right, and then that leaves us with our quadratic formula. So I'm going to start with what goes on the top there on the blue on my particular packet. So we're going to start off with that when to use. And honestly, any quadratic can be solved using the quadratic formula. But usually I go to this method when it is not factorable or not easily factorable. If I can factor, I go to that method first. Again, you need to make sure it's set equal to 0. That is the case. Then you need to identify A, B, and C. So that we can substitute them in. And the formula that we're going for here is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that's why we need to identify the a, b, and c. Then we need to substitute those values into the formula. Then you're going to use your order of operations to simplify. Then you may have to reduce if possible. And again, we're looking for whether or not we have one answer, two answers, or no real answers. And we're going to look at an example that will go on the bottom here in just a moment. So now down on my orange part is where I'm going to write this example. X squared minus 8x plus 14 equals 0. When you look at that, you think maybe I'd be able to factor that, but your multiplication would be 1 times 14. So you need two numbers that multiply together to make 14, but add up to negative 8. Well, the only way to make 14 in multiplication is either 1 times 14 or 2 times 7, and neither of those is going to get you to add up to 8. So that's where we're going to fall back to our quadratic. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So I'm going to identify my a, my b, and my c. So in this case, a is 1, b is negative 8, c is 14. So I'm going to substitute in those values. Now you do have to be cautious. The formula starts out with negative b, so when I substitute that in, I have a negative 8 plus or minus the square root. Negative 8 squared, I want to square that quantity. So make sure when that goes into my calculator, I'm squaring that correctly. Minus 4 times 1 times 14. And that's all going to get divided by 2 times 1. Well, a negative 8 would give me positive 8 plus or minus the square root of 64 minus 56, all divided by 2. So x equals 8 plus or minus the square root of 8 divided by 2. The square root of 8 can be simplified to 2 radical 2. We've talked about taking that square, if there's any square roots out. If I look at the number 8, 8 is 4 times 2. 4 is a perfect square, so I can take the square root of that. So x equals 8 plus or minus 2 radical 2 divided by 2. And this separates out into two separate problems here. X equals 8 plus 2 radical 2 divided by 2. And x equals 8 minus 2 radical 2 divided by 2. Now we do have a situation where 2 will divide into all of these. So divide that down to 4, 1, and 1. So 4, 1, and 1. So x equals 4 plus radical 2 divided by 1, which we wouldn't write the divided by 1. So x equals 4 plus radical 2. And then here we would have x equals 4 minus radical 2 divided by 1, or just x equals 4 minus radical 2. And you could leave this answer as x equals 4 plus or minus radical 2. But those would be the solutions of where this quadratic is going to cross the x-axis. So now you should have your flip chart complete, and you'll be able to use this now on the worksheet as a review.